This is neutral way and net ID is ZN236. I'm doing question 1 in homework 3 and let's start. First question. Find B so that the probability of x equals k represents a probability mass function. Okay, we will use this property to solve this problem. K equals 1 and infinity p. Okay, so assume Sn is it's the first formula, and we can get this from question here. And because we want to solve this problem, use the geometric progression. So we know here will be okay. And we can use the first formula minus the second. For example, here we will get p to 1, and the last item will be remained. So here we get we can see this is the geometric progression. We can just get the sum of them. So here we know sorry, here is minus. Okay, and put this into this way. Equals to 1, and when k go to infinite, because p is less than 1, so p to k will go to 0. So we can just change this formula to this way. And it's very easy to calculate. So b equals to 1 minus p to 2. Okay, the second question, we need expectation of x. So from the definition, it will be okay, and here we can change it. But it's very hard to calculate, so we want to get around k. We can use derivation. Okay, you can see here we get rid of a k, so you can see, and use the same way. Finally, we can get here. And we will see here is geometric progression again. So we can write it okay. And also when k to infinite, p to k will go to 0, and it will be now it's very easy to calculate, so the result will be okay. This is expectation. So we solve the second problem. The third problem, we need to know the expectation of x to 2. Okay, from the definition, again, we get this and change the probability. Now k to 3, we can use the same way as the second problem. Finally, we get this. Geometric progression again, and it's very to calculate, just take some time. The result is this. Okay, the fourth question, it's okay, expectation of x to 2 minus expectation of x. It's very easy because we know this one and we know expectation. It's very easy to calculate, okay? So I just write it down directly. And the result is this one. Okay, the last question. Let's see. Okay, p equals to 1/3, and we need to calculate. Let me see. Sorry. Say the conditional probability mass function. Okay. Equals k when x to 5. And now we will know b is 4/9. Okay. We will change this in another situation, because this is the property of conditional probability. Okay, then we can change this in another way. Here, Here we can see the numerator need another limitation, so we write it down. K takes 2 or 3 or 4 or 5. And we know this part we can calculate, but it's a little bit hard, but we can get the result. Here is not exact value. Okay. Now we solve this problem. The function is this. Okay. Thanks for watching.